So if we look at this flowchart up here, the first stage says identify the known and target substance. And the example refers to a different question, obviously. It might be on this worksheet, but it's not this first one. So let's highlight the known substance. So it tells us that we've got 10 grams of titanium chloride. So that's the stuff that we know. The titanium chloride is the known substance. So I'm going to highlight it here too. Maybe not quite so dark. That's my known substance, right? Now, target substance is the one that it's asking me to find out. So it's asking me calculate the mass of sodium. So sodium is my target substance, and that's this one here. Okay, that's my first stage. Of the next one is to find out the molar mass of each substance, target and known. So we just for practice worked out the molar mass of all of them, but let's just highlight which one is which. So the molar mass of sodium, the target substance, is this one over here, and then the molar mass of the known substance, which is titanium chloride, is this one over here. That's the final answer. So we've got we know which one's the target, which one's the known, and we also know the molar mass of each one. The next one is to convert the mass of the known substance into moles. Well, if we know that 1 mole of titanium chloride is 346 grams, then how many moles would be 10 grams? Well, it's clearly going to be much less than 1 mole, because 1 mole will be 346 grams. We've only got 10 grams here. So it's going to be a fraction, just a fraction of 346 grams. So the way you would do it is, and we could think about this. I will give you the formula in a moment, but I want us to sort of visualize how to understand these formulas from first base, from a basic idea. We know that 1 mole would equal 346 grams. Okay, and we could therefore imagine how much 2 moles would be, right? If 1 mole is 346 grams, 2 moles would clearly be 346 grams times 2, right? That makes sense, doesn't it? Yeah. So from this basic understanding, we can now work out what the formula is. In other words, what we've done from that examples there is that the moles must be equal to the molar mass, or we can call it the molecular mass, times number 2. Oh, hang on a second. No. Oh, wait. Yeah, times the... Hang on a second. What am I doing here? Oh, yeah, sorry. I've got that wrong. The thing that I've just worked out, once I multiply 346 times 2, would be the mass. So the mass... So this is... Remember, this is the mass of... And, yeah. So the mass of 1 mole, the mass of 2 moles. Okay, so therefore the mass is equal to the molecular mass multiplied by the number of moles. Okay, so now we've got the formula. We could also put that into a triangle. So we could go, how do we make triangles from a formula? Well, we look at the right-hand side of the formula and we go, well, there's no dividing thing. So both these go at the bottom. And then we draw the dividing line, and wherever the gap is in the triangle, we put the thing on the left. So now we've got a formula triangle as well. And so we can calculate whatever we want from using this formula triangle. We've got, what did it say in our stages? Convert the known substance into moles. So we've got the mass of the known substance, which is 10, and we've got the molar mass, or MR, or the molecular mass, which is 346. So the moles is going to be equal to, so the moles of titanium is going to be equal to 10 divided by 346, which kind of makes sense, because if it was the other way around, if it's 346 divided by 10, we're going to get a large number. We know we're expecting a small number because it's much less than 346. So the number of moles of titanium chloride, it's going to get a little bit messy now. I might just make the board a little bit bigger. And then just move this. Oh no. Move this up here. So the moles of titanium chloride is therefore going to be equal to the mass that we know, the 10 grams, divided by its molar mass, which is 346 grams per mole. And if you get quite good at algebra, you can apply these understanding of algebra to these units and see that the unit is going to end up being mole by looking at. You can see the grams are going to cancel out. The moles is going to end up at the top. I won't go into too much into detail why that is, but in any case, so we go 10 divided by 346, and it's quite a small number. It's 0.03 rounding up. Okay. So now we know the amount of moles we've got of the titanium chloride. We look at, what does it say in the next one? Stage 4, it says use the equation to find the ratio of the known to the target substance. Well, that's what we'd said at the moment. That's what I said with the if. If I had 1 mole of titanium chloride, whatever, right? So 1 mole because 1 mole of titanium chloride would react with 4 moles of sodium to produce and all that. But actually, we only need to be interested in the known and the target substance. Looking at this formula here, the ratio is 1 to 4. So if I had 1 mole of titanium chloride, I could react it with 4 moles of sodium. Okay, so it's 1 to 4. I don't have 1 mole. I only have 0.03 moles, but I know that it's 4 times the amount. So the moles, so this is the final stage, the moles of sodium required would be 4 times the amount because the ratio is 1 to 4. So it's going to be 0.03 times 4, which is going to be equal to 0.12 moles. We haven't finally got the answer yet. We've just calculated the number of moles, right? That's the moles of sodium. Remember, we want to know the mass of sodium, all right? Because we're going to be weighing it out and we want to carry out our experiment correctly. So what do we do now? We go back to our triangle. And we know how many moles. We also know the amount of the molar mass of sodium, which is, we worked out earlier on, was 23 grams. Okay, 23 grams per mole. So the mass of sodium is going to be equal to the molar mass, which is 23 grams per mole, multiplied by the amount of moles that we've just worked out we will need, 0.12. Whoops, I did an equal sign. I should have done a time multiplication sign. Okay, let's just get rid of that. Don't need that. So we do 23 times 0.12, and that gives us 2.76. Providing I've not made any silly mistakes, that should be the answer, 2.76 grams. Okay. So that was the bit your friend was talking about. It gets a bit more complicated because you've got to apply all those things but I've made it a bit easier by adding those. Sorry, did you hear that? There's a buzzer. Let me just stop